Hi everyone, this is Mr. Hilko. In this video, I'm going to take you through page 59 of your Unit 7 packet. This is part of your review lesson where we're going to be going through questions 7 through 12. Now these 6 questions revolve around the first 2 lessons of the unit where we dealt with the standard form for the equation of a circle and we went through the completing of the square process. Okay. I just wanted to put this up to make sure we're familiar with the standard form for the equation of a circle, which is on your screen right now, where HK would be the coordinate of the center and R would be your radius. So we're going to be referring to that equation through most of these problems. Okay, we're going to begin with question number 7. I'm going to read the question and then do the work on a separate sheet so we have a little more workspace. So question 7, which circle has a center at -3, -6 and passes through the point -4, 8? Okay, so question 7 we're going to do on this page. Now whenever you are approaching a problem where you got to write an equation of a circle in standard form, you really need 2 things. You need the center and you need the radius of the circle. If you have those 2 things, then you can plug it into the standard form of a circle formula, and then you'll have your equation. Okay, so in this problem, we were already given the center. The only thing we need to find is the radius. Since this is the center and passes through that point, we just need to find the distance between the point -3, -6, and -4, 8. So by labeling, this would be x sub 1, y sub 1, x of your second point, y your second point. Okay, then we're going to plug that given information into the distance formula. I'll do that in red. I like to draw my square root symbol, create my binomial bubbles squared with a plus sign between them, and then fill in the information from the coordinates above. So it would be -4 minus a -3, which is really just +3, and it would be 8 minus a -6, which means that would be 8 plus 6. Then I would plug what's under the square root symbol, which is called my radicand, into my graphing calculator, as you see right now, and it comes out to be the square root of 197. Okay, so my radius would be the square root of 197. Now we can plug the information. We reached our goal. We have the center and the radius. We can plug it into the equation for the standard form of a circle, which means there's my binomial bubbles squared, and I can just plug in x. We need the opposite of the x coordinate of the center, which would be +3. Over here, we need the opposite of the y coordinate of the center, which would be +6. And then we take the radius, which is the square root of 197, and square it. And since this square root symbol and squaring a term are inverse operations, it would just be 197. Going back to the sheet, is that an option? Yes, it is. It is choice letter A. Okay, so that was number 7. Number 8. The question for number 8, it says the center and radius respectively of the circle 4x squared plus 4y squared minus 32x plus 24y equals -96r. So we have to complete the square on this equation in order to get the circle in standard form, and then from there pull out the center and the radius. Now the one little twist on this problem is, in order to complete the square, the coefficient on the x squared and y squared term have to be 1. So the first thing I'm actually going to do is I'm going to divide every term by 4. Okay, and if I do that, I get x squared plus y squared minus 8x plus 6y equals -24. Okay, now I'm going to figure out where the boxes go, reorder the terms, and get it set up to complete the square. So to do that, I have to get my x squared term and -8x together. So x squared minus 8x, my x terms. I'm going to open up a box. I'm going to do the same thing with my y terms, y squared plus 6y. So there's the y squared, there's the 6y. I'm going to open up another box. The negative 24, the term without the variable, is already on the right side, which is perfect. But since I opened up 2 boxes on the left, I need to open up 2 on the right. So to complete the square, we're going to take the coefficient of x, cut it in half, divide it by 2, and multiply it by itself. So negative 8 cut in half is negative 4. Negative 4 times itself is 16. We're going to do the same thing. Oh, I forgot to write my y here. I copied that wrong completely. Sorry, that was a 6y. Okay, so the 6, we're going to complete the square on that 6. 6 cut in half is 3. 3 times itself is 9. Okay, so from there, hopefully I can get the circle written in standard form. So on this right side, negative 24 plus 16 plus 9 comes out to be 1. What I did here is by completing the square, you create a perfect square trinomial. So you can factor it. All right, factors of 16 that add to 8, 4 and 4. So you put a 4 here. They both have to be negative 4s because you got to create a negative 8. Another way to come up with the sign is if the signs are different, it's automatically negative. So on the next one, you know since the signs are both positive, that there's going to be a positive here. But we really want factors of 9 that add to 6, which would be 3 and 3. Okay? Now from there, you can come up with your center. Because remember, you're taking this term right here and this term right there, and it would be the opposites. So it would be 4, negative 3 would be your center, and your radius is the square root of the 1. Square root of 1 is 1. So the choice that we're going to select for that one, with a center of 4, negative 3, and a radius of 1, looks like it's O. Letter O. Okay, so that was number 8. The next one, number 9. Okay, this one was one of the more challenging ones because if you look at the problem, it says which circle has a diameter whose endpoints are 4, negative 1, and negative 6, 7. Okay, now we're not given either. We're not given the center or the radius, which are the 2 things we need. So we have to think about in what ways can we get the center and the radius. Okay, I am going to just draw a quick little sketch here. Pretend that you know, well, you know you have a circle, and you were given 2 endpoints. Okay, now our goal is to find the center and the radius. Okay, so the center would have to be the midpoint of those 2 endpoints. So that's actually the first formula I'm going to use. I'm going to use the midpoint formula on the 2 endpoints of the diameter, which would be 4, negative 1, and negative 6, 7. Now that's the midpoint formula, but some of you know that you don't have to really write it out every time because to find the midpoint, you just average your x-coordinates and average your y-coordinates. So it would look like this. Taking your x-coordinates and averaging, meaning you add up your x-coordinates and divide by 2, doing the same thing with your y-coordinates. Add up your y-coordinates, divide by 2, you get a midpoint of negative 1, 3. Okay? So now we know the center is negative 1, 3. Now there's a couple different ways you can get the radius. Since this is the midpoint, and we know the endpoints of the diameter, we could take the midpoint and one of those endpoints and find the distance between them. All right. However, what I often like to do is just use my original 2 endpoints of the diameter and then cut that length in half. Okay. So this is x sub 1, y sub 1, x sub 2, y sub 2. I'm going to put it into the distance formula. So it would be x sub 2 minus x sub 1, negative 6 minus 4. And then it would be 7 minus a negative 1, which would be 7 plus 1. So it would be the square root of, going to the calculator. So you can see, negative 6 minus 4, I'm putting the radicand in, plus 7 plus 1 squared. The radicand comes out to be 164. Now what we have to remember is that represents, since that went from the endpoints of the diameter, that represents the length of the diameter. We need the length of the radius. So we're going to take that radical 164 and we are going to divide it by 2, and I get 6.403124237, ... So that's actually an irrational number, which is a little odd. All right, I'm just going to see how this turns out. I don't believe I made a mistake, but I'm just going to continue with it. Now I'm going to try to write the equation of my circle. All right, so filling in the information. X, the center had an x coordinate of -1, so this would be +1. Y, the center had a y coordinate of +3, so this would be -3. Now this position represents the radius squared. So I'm going to take this number, since it's already in my calculator, and square it, and you end up with 40.999 repeating, all right, which is 41. The reason it's not 41 exactly is it actually rounded this number, okay? That was an irrational number, and it rounded it, so then it changed this value a little bit, okay? But then going to the answer sheet, question number 9, it looks like the answer would be letter G. Oops, I can't see that. Letter G. Okay, so we got the first 3 down. Let's do the next 3. This one potentially looks like it could be a little shorter. Now, here's the deal with the next one. It says, let me scroll up. 10. Which choice is the equation of a circle tangent to the x-axis whose center is at 4, -6? So I want to deal with the idea of tangent to the x-axis. So the first thing I did is I drew a quick sketch of my coordinate plane, plotted the center, so I know the center, okay, is 4, -6. How can I get the radius? Well, if I think about the word tangent, tangent means the circle can only intersect the x-axis at one location. So if this is the center and a circle could only hit the x-axis intersect at one spot, it would have to be at that point, right? Because if you think about it, like that would be the circle, all right? So the radius would actually be that distance there, and if you use the coordinate 4, -6, you know since you went down 6 that this radius would have to be 6. So the radius is 6. Now we have the center and the radius, which were the 2 pieces we are always trying to get, and we could put it into the standard form for a circle. X, the opposite of 4 is -4. Y, the opposite of -6 is +6. And we're going to square the radius to get 36. Okay, so looking over at the answer sheet here for 10, it wouldn't be that one, which I thought it would be. It wouldn't be this one because it has 16 instead of 36. So it's either got to be E or D. All right, now the issue is E and D aren't written in standard form. So there's a little more work that has to be done. But I think we can shorten up the work a little bit, because you see how this term is negative and this term is positive? That might lead us to the right answer and help us save a little bit of time. You see how the x terms are both positive? So but this was negative, and if we complete the square, it would have came out to be positive. And since these are different, it would have been negative. All right. But here, since the signs are opposite, it would have been negative, and the y terms are both positive. This would be positive, which is what we want. We want a negative and a positive. So I believe that D would be the right answer, but I really got to verify it. So to verify it, I'm going to complete the square on D. I'm going to put x squared minus 8x, open up a box, plus y squared plus 12y, open up a box. The 16 moves to the other side, and I open up 2 boxes. So let's just verify that if I complete the square on that equation, I end up with the equation above. -8 cut in half is -4. -4 times itself is 16. 12 cut in half is 6. 6 times itself is 36. So on this side I get 36, which is exactly what I want. And when you factors of 16 that add to 8, they're both 4s. The signs are different. Negative. Y, factors of 36 that add to 12, they're both 6s. Since the signs are both positive, it's positive. this equation matched up. So that verified that the answer to choice 10 was definitely D. Okay, that was 10. Let's do 11 next. So 11. Which choice is the equation of the circle with center -3, 4 and passing through -6, 0? Very similar to one we already did. Okay, we know the center. We need to find out the radius. All right, since we know the center, let me write these down. Since we know the center and a point that the circle passes through, the radius would represent the distance between those two coordinates. Okay, so I'm going to use my distance formula. There are my labels. Distance formula, binomial bubbles squared. It would be -6 minus a -3, which makes that a +3. Y sub 2, which is 0, minus y sub 1, which is 4. Distance equals square root. Put the radicand into your graphing calculator. So we have -6 plus 3, close parentheses, squared, plus the binomial 0 plus 4. Square root of 25, which, since it's a perfect square, it comes out to be 5. So we know our radius is 5. From there, let's write the equation of our circle. X, opposite of your x coordinate, +3. Y, opposite of the y coordinate of the center, would be -4. The radius squared, 5 squared is 25. Let's see, we're getting a little groove now. Is that option listed? And it looks like it is. Choice L. Okay. Number 12. Last one we'll go through. Ignore the bottom for now. Let's just focus on the top. 12. Let me just read the question. Which of the following points lies on the circle with a center whose coordinates are 1, 2, and a radius of 4. So that's actually really nice. We already know the center and the radius. So I can actually write the equation of the circle in standard form. It would be x minus 1 squared, and the quantity y minus 2 squared. The radius squared would be 16. Okay? But this question was a little different because it said which of the following points lies on the circle. Okay? So the problem wouldn't be as repetitive. What I wanted to do, and I did this ahead of time, is I took the 4 different options and then we're plugging the point into this equation above. So this would be x and y. This goes in for x and y. This goes in for x and y. This goes in for x and y. And you just want to see which one works out. Okay? So when I plugged it in, all right, I plugged a 0 in for x and a 6 in for y. Here you'd get -1 squared, which is 1. Plus 4 squared, which is 16, you end up with 17. 17 does not equal 16, so it wasn't letter F. Here you end up with -4 squared, which is 16, plus 5 minus 2 is 3. 3 squared is 9. You end up with 25. 25 does not equal 16. It wasn't that. Choice A. Was it choice C? Let's see. 2 minus 1 is 1 squared, which is 1. Now look what happens here. Even though it was a funky one to plug in a little bit, the +2 and the -2 cancel out. You have radical 15 squared, and since these are inverse operations, you just get 15. 1 plus 15 is 16, so that's the one that checks out. It looks like the answer to 12 is C. Okay, so those were the answers to the top half. For the bottom half, instead of going through each one and creating a super long video, I decided to give you the answers. All right, it was a matching activity. For some of them, you had to complete the square, like 14, 16, 17, 18. For others, you could probably pull out the information because it's already in standard form. But I didn't want to create a video that would be too long. Okay, I appreciate you guys listening. Hopefully that helped out. If you do have questions on 13 through 20, I'm sure you could ask either myself, Mrs. Ebers, or Mr. Mazzaroni during our office hours. Appreciate your time. Have a nice day.